So I get up pretty early to do sort of an extended morning workout. It involves running and a lot of time on the treadmill. And I got up early today, and because I realized that the new romantic comedy, Marry Me, starring Jennifer Lopez and Owen Wilson, was available to watch on the Peacock streaming service that I get for free through Comcast, I decided to turn it on the treadmill and watch it. I thought I was going to see sort of a silly wish fulfillment romantic comedy, and instead I ended up watching a silly wish fulfillment romantic comedy that featured representation of math teachers and math teams and math coaches, and actually a number of legitimately interesting math problems. Pretty much scaled, I would say, to the level of competition and the ages of the competitors in the films, although that was a little bit nebulous. So after thinking about some of the problems, there was only one that sort of stood out to me. It was the one that I actually thought about the solution to while I was on the treadmill watching this climactic scene. And again, I'm going to avoid spoilers, but I am spoiling it to tell you that there is a huge math competition that coincides with the climax of the film, which just sort of like, I don't know, tickles my funny bone, whatever the word would be. So I won't show any clips from it out of interest of not getting copyright struck, but I will post that little screenshot of it. So there's a problem in the background that a character has to solve in this competition. And when I heard the problem, I just thought it was interesting. So I'm going to solve that problem. And in fact, I am attacking the math of Marry Me, the 2022 romantic comedy that just released last night. So here we go. So the problem, as stated by the Mathlete proctor, and the competition that they were in resembles a little bit like, I think it's the Math Counts or Countdown. I don't know if that's the exact name. I haven't gotten to participate in that one before, but it's similar to that, where there's like individual performers answering specific questions here. Middle school age for the most part. So the question was, a circle with perimeter 8 pi is inscribed in an ellipse, whose ellipse is twice its height. What is the area of the ellipse in square units? Now, it's a little bit of an interesting question. Not only because I think what piqued my interest was the fact that they said that a circle was inscribed in an ellipse, and I had to think about that for a moment, although they did, too, have a picture. This was me creating in Desmos. You saw it in the last one. But, in fact, when I heard the problem the first time, I actually misheard it and assumed they said a circle with area 8 pi, simply because we don't usually hear people talking about the perimeter of a circle. They'd say circumference. So, one tiny point off for the mathematical quality of what's in the romantic comedy Marry Me. But otherwise, good, solid, interesting question. So here it is. We've got a circle with perimeter or circumference 8 pi. It's inscribed in an ellipse, as we can see over there, creating sort of an eyeball shape. Kind of cool. And it says the ellipse has a width that's twice its height. We want to figure out the area of the ellipse. So a couple things to note. The first thing that I want to attack here, really briefly, and I'll try to use Valentine's Day colors as much as possible. If the perimeter of a circle is 8 pi, that means its circumference is equal to 8 pi. And I'll remind you that the circumference of a circle, aka its perimeter, is twice pi, or 2 pi times its radius. That's going to mean that our radius length for that particular circle is 4. 4 units. I guess I'll use units since they did ask for square units. So 4 units long for the radius. Now, based on that and what we know about ellipses, basically it's almost like an ellipse has 2 radii. So basically, if we have r equals 4 units, then as we can see on our ellipse, what we'd call the minor axis of the ellipse is also going to be 4 units. And because of the fact that the width is twice its height, that means that we can definitively say that the major axis of this ellipse is going to be 8. That's sort of like its bigger radius, if you want to think about it that way. So cool. We have identified both the minor axis and the major axis of the ellipse. Great stuff. The question would be, well, what's the area formula for an ellipse? And the answer is that, yeah, you might not actually know this. You might not have run across this. I ran across it in a Calculus BC lesson that I did. I had our students use, I believe, Trig substitution to derive the area of an ellipse. But that's okay. I'll just present it to you. So the way I think about it is that the area of a circle is pi r squared. And we can think about it as the major and minor axis of a circle are the same thing because the circle has a uniform radius. It's all points equidistant from a center. So the area of an ellipse is the same basic thing. It's pi r times r, but the 2 radii are different. We have the major axis and the minor axis. So in this case, the smaller radius up there is going to be 4. Oh, I didn't even say what the formula is. The area of an ellipse here. I'm getting all excited talking about this. The area of an ellipse is equal to pi times a b. where A and B are the lengths of those little radii. I keep calling the major and minor axis. I'm pretty sure that's the terminology. It's been a little while since I did intense conics. So in any event, though, to answer our question, since we wanted the area of that ellipse, obviously pi is there. The minor axis, or the shorter of the two radii, would be 4, and the length of the longer radii would be 8. When you combine this stuff together, we get an answer of 32 pi. And of course, it wants it in square units, so I'll just add units squared, just to be safe. But there is my answer. Now, does the character answer the problem correctly? You'll just have to watch Marry Me to find out. You'll also have to watch Marry Me to figure out whether or not Jennifer Lopez and Owen Wilson, the math teacher and math team coach, I might add, get together in the end. But it is a lighthearted romantic comedy, so I'm thinking you could probably figure that part out. In any event, thanks for sticking around for the short discussion of The Math of Marry Me, the 2022 romantic comedy that's now featured in theaters near you, as well as on the Peacock streaming service, which you might have access to if you have Comcast or Xfinity or maybe even another service. Regardless, thanks for watching. Go watch that movie. It's a good enough movie, I think, to entertain you on Valentine's Day weekend. And thanks for watching.